Hello, my name is Fu Chai. My student ID is 0358346 from Section 5, Group 20 at Taylor's University. Welcome to my group assignment video presentation for data mining. In this video, we cover 4 data mining techniques applied to the Connecticut accidental drunk-related debt dataset. First is agenda. We start with a dataset overview and problem statements. Walk through per-processing, then cover classification, regression, clustering, and anomaly detection. Each week, a brief code demonstration. We close with an evaluation summary and conclusion. Dataset overview. The dataset contains 11981 records across 48 columns spanning 12 years from 2012 to 2023. The 4 call-out boxes summarize the headline figures. Most significantly, phantom was detected in 67.2% of all cases, the dominant substance throughout this dataset. Annual debts rose from 355 in 2012 to a peak of 1524 in 2021. A 329% increase before declining to 1327 in 2023. The dataset also includes GPS coordinates, which we use for geographic clustering. Problem statement. We formulated 5 problem statements in Assignment 1, each matched to a data mining technique. Problem 1 use classification to predict phantom debt risk. Problem 2 use regression to forecast monthly debt trends. Problem 3 use clustering to identify geographic hotspots. Problem 5 use anomaly detection to flag unusual case. Problem 4 shown in gray was association row mining with AppRory and FPGrow, fully completed in Assignment 2 and therefore excluded here to avoid technical duplication as required by the module instruction. Data preprocessing. Our preprocessing pipeline has 6 steps. Step 1, drunk binary encoding. The 22 drunk column use Y for detected and blank for absent. Converted the binary integers 1 or 0. Step 2, missing values. H had only 2 missing values filled with the median of 44 years. Intensity and 78.6% missing was excluded entirely. Step 3, categorical encoding. Sex, race, and location were standardized and labeled encoded to integers for the tree-based and distance-based models. Step 4. Data passing PD to datetime with arrows equals cross drop tree. A perceivable record, year and month were extracted as integer features. Step 5. Geographic parsing. The injury city draw column stores city name with coordinate placed in parentheses are regular expressions extracted latitude and longitude, giving us 11724 geotag records for clustering. Step 6. LLM verification. A large language models confirm that the any appeared. Aggregate column should be excluded to prevent collinearity with the individual's appeal indicators. Classification. Our classification task predict whether a debt involves phantom's binary target. 1 for detected, 0 for non-detected. We choose random forest for 4 key reasons shown on the left. It handles nonlinear drunk interaction patterns naturally. Class balance compensates for the 67 to 33 class imbalance without resampling. It provides features importance for clinical interpretability and the ensemble of 100 trees reduce overfitting compared to a single decision tree. The right panel shows the model configuration 103 max step 10 minimum 10 samples per leaf with a stratified 80 divide 20 train test field and 5 for cross validation to confirm stable generalization. Classification code demo. Here is the actual Python code for the classification implementation. Code snippet 5 define the features matrix, age, sex, race, location, plus all drum columns except Fantize itself is our target. Code snippet 6 perform the stratified trains test spills test size equal 0.20 with stratify y ensures both partitions preserve the 67 divide 33 class ratio. Code snippet 7 instantiates the random forest. You can see the key parameter highlighted on the right. Estimator equal 100. Max step 10 and class very balanced. The model is then trained with RF cliff fit and complete in about 1.4 seconds on this dataset. Classification result. The result test accuracy 74.80%, AUC ROC 0.8298, F1 score 0.80, and 5-4 cross validation of 73.21% with a tie standard deviation of 1.16%, confirming stable non-overfitted generalization. In the table, paration of 0.787 means 87% of predicted Fantize cases are correct. Record of 0.73 means we correctly identify 73% of actual Fantize cases. The roughly 434 false negative represent misdiagnosis intervention opportunity reflecting the classification difficulty when Fantize appears in 67% of all records. The top predictive features is Heron mark code in consistent with the pharmacological co-occurrence we found in assignment 2. Next is regression. Our regression task focus mainly on that counts addressing problem 2, given policymakers a 12-month forward view for resources planning. We use whole winter stripper as exponential smoothing, which decompose the series into 3 components on the left. The level 1 with alpha 0.218 tracks the local average. The trend with beta optimized to 0 reflect that the trend flattened. After the 2021 peak, the season 1 component with gamma also near 0 means the model released on the historical average seasonal pattern. We trained on January 2012 to December 2022, 132 months, and evaluated on the 12 held-on months of 2023. The results on the right are strong. MAE 44.7, RMSE 59.3, and MAPE 3.8%. By Lewis 1982 score, below 5% is classified as highly accurate. Our 2024 projection of 1250 to 1380 annual depth showed a continual modest decline from the 2021 peak. Regression code demo. Here is the regression implementation code. Code snippet 13 perform the train test build TS20221201 for training and TS202301 for testing, ensuring Exactly 12 test months, co-snippet 14. Instantiates the exponential smoothing models. You can see the three clear arguments trend at seasonal at and seasonal periods 12 for the annual cycle. The model is then fitted with optimized truth, which means the smoothing parameter alpha, beta, and gamma are all automatically found by minimizing the sum of square errors. No manual turning required. Next slide is clustering. K-means clustering on GPS coordinates of 11724 record identify geography sub-regions of Connecticut with elevated drown mortality density. The left panel shows how we selected K for the L-box medals show an inflection at K4 at the seal-halted score peaks that are 0.4713 coordinate were standardized before fitting to keep latitude and longitude on equal footing and end in need 20. Ensure we find the global minimum. The validity matrix on the right seal-halted 0.74713. The west boarding 0.7467. Kaliskin Harbase 13914 confirm the four clusters are meaningfully separated. The four regions at the bottom, cluster 0 Eastern City has the highest lodging prevalence. Cluster 1 Southwest City Bridge Geport the highest concern. Cluster 2 Central City for the highest Hyun and Cluster 3 non-central city has the higher overall fantasy 1 and 71.4%. Next is clustering code demo. Code snippet 19 show the K selection loop for each K from 2 to 10 we fit. A K-means model record the inner tier and compute the halted score. Both metrics are then plotted to generate the output and halted charts. Code snippet 20. Fit the final model's best K equal 4 and we use n init 20 and max ether 500 to ensure convergence to the best solution. The cluster labels are then assigned back to the date from which fix predicts. Next is anomaly detection. Isolation for us in identifying that record with statistically unusual combination of age, drown, substance, and location type. We use 200 trees with a contamination parameter of 5%. We detected exactly 599 anomalies, 5% of all records. The comparison on the right shows the key patterns. Methadone is 30.1% in anomalized versus 7.9% in normal record, a gap of 2.2 percentage points. The largest difference, fentanyl's analogy show 25.4% versus 7.2% and lysine 4.2% versus 8.2%. The inside box summarizes this co-occurrence of methadone, fentanyl analogy, and lysine suggests complex polysubstance profiles. Maxine maintains terrified with illicit fentanyl variants a potential early signal of an emerging fault opioid with then variants futures investigation. Next is anomaly detection code demo. Code snippet 23 builds the features matrix. Each is scaled using standard scalar, then join with location ENC and the 19-drum binary indicator to produce XANON. Code snippet 24 instantiates the insolation forest. You can see an estimated 200 for stable anomaly score and contamination 0.05, setting the expected anomaly rate. After ISO forest fee, predict returns +1 for normal record and -1 for anomalies while score samples give a continuous anomaly score where 1 over values means more anomalies. Last is evaluation summary. This slide brings together all four technical. Classification 74.80%, accuracy AUC 0.8298, F1 0.80, CV 73.218%, regression MAE 44.7, MAPE 3.8%, 2024 forecast show continued decline. Clustering cell halted 0.74713, CHI 13915 for meaningful CT subregion. Anomaly detection, finite anomalies, leading 3 times higher possible for wave. Last is conclusion. Our 4 key findings. Finding 1, random forest at 74.8% accuracy identifies Ventis risk. Hidden smog, Condiin, and Lazing are the top predictors. Finding 2, hot winter MAPE 3.8% enables proactive planning. 2024 project Rolling 1300 depths a continuous decline. Finding 3, K-means reveals for distinct city subregions fit different drum profile. One policy does not fit all. Finding 4, insolation forest flag finite anomalous record with elevated metadon co-occurrence, a potential fault appeared wave signal. Limitation 2.1% of record length coordinates intensity is mostly missing. Contamination threshold is a domain assumption future word. Ceramic speed, Naloxone and score economy regresso clinic LMP on course of that test. That's all for my presentation. Thank you.